This one. You have to write down this one as the answer. No question. No question, then we continue. What they say, the total fees collected is 60x plus 70y. Okay, so you look at this inequality here. I don't know how many students are there. That's why I cannot know exactly how much fees is collected. So I call the fees collected K. Can you see here? K equals to 60x plus 70y. 60x plus 70y. So this is the fees collected. The fees collected is K. Okay. Then I want to maximize the fees collected. I want to maximize the fees collected. Okay. Now, I need to draw a certain line. The line for this K equals to 60x plus 70y. Unfortunately, I do not know the value of K. So I cannot draw the exact line. But I still can draw the line according to its gradient. According to its gradient. So I change this equation into gradient form. So when I change the equation to gradient form, it becomes y equals to negative 6 over 7x plus k over 70. From this y equals to mx plus c, I cannot plot the point, the y-intercept, which is k over 70. I cannot plot because k is unknown. However, I know the gradient of the line. The gradient of the line is negative 6 over 7. How to plot this gradient negative 6 over 7? So first of all, I have to take 6 units vertically and 7 units horizontally, right? So I'm going to show you how to do. Okay, can you see the red color line and the red color label? Highlighted red color. So I plot 6 units on the vertical axis, right? And I plot 7 units on the horizontal axis. This denotes the gradient negative 6 over 7. Now I'm going to join the point here, 60, and the point here, 70 here. So I'm going to join these 2 points. Sorry. I'm going to join these 2 points like this. So I join these points like this, from 60 until 70 here. I cannot draw the full line because this is not part of the graph. So I use dotted line to join the 2 points. And this produces the objective function, what we call the objective function, right? Now I want to maximize this line or minimize this line, which is the objective function. How to do it, all right? So first of all, you use one ruler. You use one ruler and you place this ruler on the objective function that you have drawn. Do you know what I'm doing now? Draw the objective function, the gradient of the objective function, then put the first ruler on the objective function. Okay. The second step is put another ruler perpendicular to the first one. Put another ruler perpendicular to the first ruler. So the gray color is the second ruler, the blue color is the first ruler. And I try to slide this first ruler along the second ruler. By sliding this first ruler, I actually change the value of the objective function. I change the value of the objective function. So this objective function, if I pull it nearer and nearer to the origin, the last line that it hits the shaded region is this one, is this point here. I show you the point, is this point, is this point C here. The coordinate is 3.33, 13.33. Now, when we want to organize a course, our aim, our objective is not to minimize the fees collected. We want to maximize the fees collected. So this objective function, if I pull it to the lowest point in the shaded region, it will produce the minimum fees collected. This is not what I want. I want the maximum fees collected. That means I have to push this objective function furthest away from the origin. Now the point which is furthest away from the origin will produce it is the maximum point, and it will produce the maximum fees collected. So how am I going to do this? I'm going to slide the first ruler along the second ruler. So the first ruler enters the shaded region. As I move further and further away, right, I am actually very happy because I'm actually increasing the number of students and the fees collected. So further away, I reach the point B. Now B is still not the furthest point. That means if this objective function reach the point B, and this will be the amount of fees collected when I have 35 students and 45 students respectively. But this is not the maximum, right? So I push the line further and you see which is the maximum point. The maximum point is A. The maximum point is A. So when I take in 16 management students and 64 finance students, I will get the maximum fees collected. Okay, so you memorize this point, the maximum point here, right? Then let's see. Okay, right. Okay, so you see that k equals to 60x plus 70y. Okay, and I have found out that the maximum point is 1664. I use these pairs of values and substitute into the objective function k. So it's over here, 60 times 16 plus 70 times 64. This is the fees collected. Not only it is the fees collected, but it is the maximum fees collected because it comes from the maximum point in the objective function. So now I know the maximum fees collected is 5,440. As I slide this ruler along, you can see the value of k changes, Then the points change, the k also change. You can see the value. Now, here this is the minimum one. It's around 1,126. Right? This is the minimum fees collected. You look at this number here, right? So as I move further and further, As I move further and further, you can see that this number change, the number k change. It keep increasing until it is about 5,040. When it reaches A, it's about 5,440. If you move it up, the value is more, 5,900. but then the objective function is outside the shaded region. If it is outside the shaded region, then you cannot use any point outside the region, right? So although the fees may be collected is higher. Okay, any question?